Hi, everybody. My name is Katelyn, and today we're going to be talking about different types of intermolecular forces. Now, remember that intermolecular forces occur between molecules, not within molecules. And there are three different types of intermolecular forces we're going to talk about. London's dispersion forces are going to be the weakest, and hydrogen bonding is going to be the strongest intermolecular force. So we're going to go jump right into it. London dispersion forces are basically the polarization of the molecule causing attractive forces between neighboring molecules. And what this really means is that there's a temporary attractive force that results when electrons from two adjacent atoms or molecules occupy positions that make the atoms or molecules form temporary dipoles, or temporary places where there's a positive end and a negative end. And London dispersion forces, one of the most common things that I see people get wrong about this is them thinking that that only occurs in nonpolar covalent bonds. And that is what it's typically associated with, because there's no permanent dipole that occurs between two nonpolar covalent molecules. But unfortunately, the important thing to know is that London dispersion forces occur in all types of intermolecular bonding. If dipole-dipole is present, London dispersion forces are also present. So that's always going to be a common theme within intermolecular bond. And you can see here, I've got that highlighted. So there's a nonpolar covalent Cl2 creating a London dispersion force attraction with another Cl2. The next thing we're going to talk about is dipole-dipole interactions, which occur when a positively charged part of a molecule interacts with the partially negative charge of another molecule. So you can see here, this little S snake guy means that it's partially positive, and this little S negative guy above the Cl means it's partially negative. So the partially negative Cl is going to interact with the partially positive H, creating that dipole-dipole interaction. Then finally, hydrogen bonding is a special type of dipole-dipole interaction that occurs only between hydrogen bonded to oxygen, fluorine, or nitrogen, or as I like to talk about it, FON, or F-O-N. This is the strongest, and the most common example of this is water. So you're going to see a positive H, a partially positive H in H2O, creating a hydrogen bond with the partially negative oxygen. So that actually has to do with oxygen, fluorine, and nitrogen being three of some of the most electronegative or having the most affinity for electrons on the periodic table. But those are our three intermolecular bonds. Please feel free to reach out to the Rinella Center with any questions, and thanks for tuning in.